Hi everyone. I got a question about hemoglobin concentration when you're using your NIRS device. It's a good question. I don't talk about the hemoglobin concentration that much. The reason is that it's a little bit less intuitive. It's a little bit more difficult to understand and to predict. But I do think there's value there. I think I've mentioned that before. And so I want to talk about this to kind of get this question, to answer this question. And this individual is seeing fluctuations in their total hemoglobin. And from, if I understand the question correctly, it's not within the specific training, even though I'm sure they see fluctuations there as well. It's kind of when they repeat trainings over time. And so they'll have different values and what that means. And I'd like to be more confident about this, but I'm not all that confident. So I tend to, I want to avoid any kind of false positives. So there's a couple things. First of all, the individual mentions the hemoglobin value is in grams per deciliter, and I know there's some softwares out there that give you the total hemoglobin value as grams per deciliter, and at least most I so it's not a gram per deciliter value, which would be a quantified value. Even though a lot of times the numbers look, because they'll be like 14.2 or something, which is kind of a range on what grams per deciliters would be. So it looks nice and implausible, but it's not. The relative values of change. So the really arbitrary units is what you usually see these values of hemoglobin stated as arbitrary units. So it could be 100, or it could be 1400, it could be whatever. So you need to be careful that it's not a quantified value. So it really should be called more like an index or something, which is what I prefer to think of it as. And then you kind of take what the values out of the question. It's more how the value changes over time, which is relevant. And exactly following up on that point is then if you take your device and you put it on again and you have instead of say 13 you have 14 and you're like, well, it's higher now. Yeah, the value is different, but I'd be very conservative about giving any kind of meaning to that change. These changes usually then have to do, because the relative values, they can be affected by a lot of different things. So it's really a path length problem with how you're using your NIS device. Adipose tissue has a big problem. Are you mounting on the exact same spot? There's a load of technical complications involved with wanting to quantify the actual NIRS signal values. That's why we use percent for SMO2, because it's a relative value, and that's why we use arbitrary units for the hemoglobin values. So I would try to, while there might be something there, I'm not very confident in any of those things. So my recommendation is for your hemoglobin index, even if it says grams per deciliters, ignore the value per se. Just say it doesn't matter what it is, when you put it on. Now, how can you use it though? You can still use it because you want to look at how the value changes. And that has to be in an acute setting. Again, you can't take it off one time and put on another time. But within your training, within your one session, how the value changes over your training, and then it's more like how does the value change from training to training. So not the value, but how does the trending information change. So you do the same type of training and the training information is completely different. So the one time it'll all go up and the next time it goes up and then down. Those are the differences that I would look for, the differences in the trending. And just so we're clear, what the trending information tells us, or the change in the value tells us, is it's telling us changes in concentration of hemoglobin. We don't know how much, but that the concentration is changing. So if the value goes up, it looks like, I don't want to make a mistake here because there's mistakes made here with the hemoglobin a lot. So I don't mean concentration changes per deciliter. Now that might happen, but generally the assumption is that the concentration per deciliter will remain stable. Now, if you make that assumption and you have an increase in relative hemoglobin with your NIRS signal, the assumption is that you now have more blood there than before. right? That's why it's showing more hemoglobin. The concentration of hemoglobin per deciliter stays constant. Therefore, if it shows more, you must have more blood. And these assumptions then follow that your THB, your hemoglobin index, is giving you an idea of blood volume in the muscle, or changes in blood volume. Now, there's a common mistake. People say, well, it's blood flow. It's not blood flow. That's a mistake. Blood flow would mean if you tied off your arm, the value should show 0 because you would have no more blood flow, but it doesn't. So it's not blood flow. It's more like blood volume, which is linked to blood flow. So those things are combined. It's not really blood flow. So if you had an increased value of an increase in blood volume in the space, usually resulting in because of increased cardiac work and kind of vasodilation and capillaries that are opening up, so now you have more blood volume. And the going down is the opposite. So you have decreased blood volume, which is vasoconstrictions, capillaries closing, muscle contraction forces, things like that, which is causing it to go down. And you see, and why this is interesting is because you see quite a few variations. So if you do some kind of classical step test where you have increasing intensity, there's much more of a regular picture for SMO2, which is what you would predict happens, and this generally happens in people. And THB has a more variation that can happen. There's still only a given amount of pictures that you see of the trending information that can happen, but they vary, and it's not always so clear. At least to me, it's not completely clear why those things always happen. I mean, I have assumptions. And these things might be linked to one of the hypotheses that I've had that they're linked to, for example, like stroke volume. Because stroke volume, while it was at one point assumed would just be linear up to about 60% of heart rate max, and then it would just flatten out. That's not true. I mean, stroke volume takes on a bunch of different forms depending on the athlete over the course of a ramp test, and that those things might be linked. So your stroke volume might be somehow linked to your THB index and how that changes. Could make sense. Those things are linked. The point being is that changes in blood volume have an important impact on your ability to supply oxygen. And there's a lot of different mechanisms and a lot of central mechanisms and local mechanisms that affect how your blood's going to flow. And some of those you might be able to read out of by looking at your SMO2 data and your THB data rather than just your SMO2 data. And I'm just going to give a few examples here so this video doesn't go too long. So one of the things is the respiratory metabolic reflex presented by Dempsey. And the core idea of that is that if in the respiratory metabolic reflex, if your respiratory muscles are in danger of fatiguing, your central system, your nervous system basically prevents blood or limits blood flow to the legs. So it does a vasoconstriction to the legs to stop performance, to protect your respiratory system from being overworked. This would mean, if you have a vasoconstriction of your legs, would be, well, we should see a decrease in total hemoglobin, right? Because you're restricting blood flow to the legs, and a decrease in SMO2, right? Because you're getting less blood flow, more oxygen you've been taking. So you should see those kind of combinations happening at high intensities. That's one of the things. Another obvious one is if you're contracting your muscles, you get a contraction effect where you're putting lots of pressure on blood vessels, which is going to decrease volume of available to have blood in it. So that's a really easy one to test. You can look at what happens with muscle contractions. And what's interesting there is which you can test quickly, which maybe a lot of you have done, if you do isometric contractions, and if your isometric contraction force is so high that it actually is higher than venous blood pressure, you actually squish your venous system shut, but not your arterial system. So you actually have an inflow of blood through the arteries into the muscle, but none of it's getting out. So while you think, well, I'm smushing my blood vessels together, it should decrease the volume, it does that. But because you've restricted outflow on the one side, you actually start pooling. So your THB value will go up and up and up until you release that contraction. So that's you kind of get to see the interplay with this volume, right? Which is interesting. But just to consider, just try to keep it simple. Is my THB going down? I have less blood volume there. And then you can start thinking about why that is. This video's already gone longer than I thought it would. But if you have more questions about that, because there's a ton, and I have a lot of questions about that, let me know, and I can make another video. Okay, thanks, bye.